Hello, welcome everybody. Welcome to Waterloo High School. So what we're going to talk about here is a project that I came up with for the CNC mill. So it is this small little level. So it is a relatively simple project. It's a project that I have pretty much already written all the G code for. Everything is there. The students are being a machine operator. So all 6 sides have been machined. It is a project where there are 4 different operations, so students have to zero it in the machine 4 times, monitor it, watch it, and hopefully get a nice little level when they're done. So one of the first things I have students do when we first get started is going to be to check the coolant. So we have 3 things we want to check. We want to check with a refractometer, we want to check our pH, we want to check our hardness. So after zeroing out the refractometer, they're going to load a sample and check it. Take the number they find in here, and actually it gets times by 1.8 for the type of coolant I have, and that gives them their number that I like to see between maybe 8 and 10%. Then we'll take one of our testers for pH. Typically we'll dip it in to the coolant, let it be there for a little while. We'll take one of our hardness, and again, typically dip that in the coolant tank. We can check out where we are, and hopefully we're near 7. Looks fairly good. Hardness, we're normally a little hard in water here, so I'm not surprised, but we're not too bad. My plan is to have a long spreadsheet that each time they come in, they got to check this stuff off, then clean up the tools, measurement equipment, put it back away, and then start their machining operations. So for my CNC projects, I always try to print out some setup sheets. So setup sheets, simple, just off a Mastercam, but they have some important information. They're going to show, sort of what's going on, what side's being machined on, somewhat of a tool path. Also, they show the students where the 000 is. So this is where the students need to indicate off of, so they set up the machine, set the work offsets correctly. I'll also give a little bit more information, so I'm telling them they need to cut a 1x3 by 3.2 inch piece of aluminum and set up on Talon grip vise. So that's the left vise in the machine as set up right now. So I like to have these. I know the students don't look at them too much yet, but just to be able to have this stuff, because as I talk to people in industry, this is what they tend to use there. So I'm trying to get students sort of in that mindset of what they're going to be doing when they get into real life. So this will have the tools. It should have the number, tool number 7, tool number 4, 15, 17, 1, 25, 14. So it has everything loaded up. Students should double check that. Operation 2, again, now they have to be looking carefully enough, because now this 00, this origin is up on the original block. So making sure they don't go off of a machine surface here after they flip it over. So that's just a facing to take the hat off. Then they can come back and get a good 00 on a machine surface, and then come in and machine the other side. Now we're flipping it upright. Again, we got to take another 00. A lot of times I'll try to remark that they got to remember to use G54 or what size parallels. We made a vise for or some jaws for this vise, so we don't need to worry about parallels anymore. Just try to make things as easy as possible, just kind of like they'd be in industry where you have all the setups basically already there. They just need to put the part in, check off where it goes, and go from there. And while I could set up some stops so they could actually just drop it in and go, I still like the idea of getting them using an indicator, finding where 00 is, plugging it into the machine, and making sure they kind of understand that that's important to plug that stuff in the machine and know where it is in the machine. So we've been very fortunate at Waterloo here to get some of this new equipment, but something like this is just simply a Harbor Freight toolbox. It works very well for me. I have locked down below. I have different storage down here, drill bits, other tooling, indicators, stuff like that. Up in the top drawer, I have most of my tooling, tools, extra jaws. These little bins, these are simply 3D printed bins got off of Thingiverse. Works very well, very easy. So these are the little vials that I use. Just purchased off Amazon. About $1 each or so. Works really, really well. There are lots of different sizes. So I know the first time I got these, I got 30 or so. We used them for the first class. And then when I went back to reorder them, that particular item was gone or not available. So I had to measure them and get the right size for another one. So I would say, try to find a source that's going to have them from year after year, or check around and make sure you get ones that are really pretty standard. I'm not remembering exactly what these are. Let's see. They're just 3/16. They're just 3/16. So I can use them with a standard tool drill bit. Standard drill bit works really well, has a nice fit where I can just pretty much push them in gently. So after students have their piece cut, then they're pretty much going to move over to the CNC. I'm going to remind them that this edge, make sure they get that edge cleared away so there isn't going to be anything sticking out that's going to prevent the piece from sitting nice and flat. You can take a file and run a file across the edges and make sure. And then we're going to put that in the left vise, or the vise with the talon grip jaws. So what these have little tiny little grips down here. These are going to grip on maybe 125 thousandths of the piece, and I have found nothing move yet. So it has a really good grip on what's going on. It is going to leave marks, especially in aluminum. There isn't much you can do about that, but it's going to hold on to it, and that being part of our waste anyways, I don't really care. So I'm going to give it a little lighter taps than normal to make sure it's down and snug it down. We don't have to be crazy tight with this because we know that it isn't going to go anywhere once it's in there. The Heimer 3D tester, I know it is an expensive tool, so it is kind of hard to justify sometimes, but it has worked really well for us. I also know there's a lot of worry from some people that the tips are going to get broken really easily. I've had this one in the machine and had quite a few students through it already. And while it's a little battered, it actually has not broken yet. So one of the things I always tell them as they jog, once they get to the point that the needle moves, they got to go to just thousandths. And then my hope is there's enough leeway in the tester that they're not going to chip it or break the tip from that. So I'm not going to show you how to do finding these in your machine, because I'm sure there are not going to be that many that are going to have the same machine as me. But once you know how to do this stuff, obviously you're going to be able to do it. So then we come back out, we're watching the needle, making sure we're not going towards the red, and then we can go a little quicker. I've found for the most part the students are really gentle with it. They take longer than I do because they go slower, which I've been really happy about. So needle moves and we stop. We go back down to our 1x and we come in slowly. Get ourselves to 0 and then plug that into Y and then back out. So if they go this way and they see it going closer to the red, they know they got to go the other way. And for the most part, it's enough times around that they have not messed that one up yet. Go back out onto the block so I can get a Z. Come down. Again, it stops, starts moving. And we get to Z. Now again, these are not going to be the critical measurements, simply because this is our first machining. So after this, it's going to matter a little bit more to make sure we're dead on. Then we can speed up a little. I always go slow till we verify which way it's turning, and we could go quicker. One other idea I had was in my T-slots here. This slot was driving me nuts because everything got in there, and because of the T-nuts, nothing ever got out. These are actually little 3D printed spacers in there, blocks. We're going to see how well they last against coolant, but so far they seem to be doing a good job. They're not, 100% flush, but for the most part, this is my setup in here. 2 vices, and it just keeps the stuff out of that crack, and I've been really happy with that so far. So how you want to do proofing is up to you guys. What I have students do is we set our common to Z to 1 inch. So I know I'm going to be machining 1 inch above the work surface. I will have their hand on the rapid feed speed and they can hit start. So they can control this and they can stop it at any time. I make sure they know that at anywhere they can stop it. Come in slow. Keep an eye on our remaining distance on our display. If it says it still has to go 6 inches, they know that's an issue. So hopefully they're going to check that. So as we come down, so usually right there as it starts moving, I'll have them take a look at it. Get kind of an eye level look at it. Does it look like it's taking off, 100 thousandths? It's not taking off 3 inches, or it's not way above it. So in this case, since I got my common at 1, does that look like about 1 inch? Yeah, I think that looks like 1 inch. It's going across one side of it, then it's going to come back and go across the other side of it. And once this program has run, I actually have pretty good faith that the program is going to run pretty flawlessly as long as they got their 0, 0. So as long as we pass the first couple passes here with the first tool, I'm happy. So now we're making a second cut on it. I'm good. I'm going to stop the machine. All right, so we get ready to make our first cut on our first operation. Again, we've checked everything. We know our work offset is correct. We've double checked that. We've checked it with 1 inch added to our Z so we can run through it if we want to. Again, this is a program that I've run quite a few times, so I'm not too worried about it. Once I know first pass, first tool is good, I'm pretty confident the rest will be, but again, students, they need to get run through the whole operation. So we'll hit the go button. I'm on this so I can slow it down. I can move where I want. Turn my coolant off so I can see. Again, I'm coming down. Starts moving in. I'm going to stop. Take a good look at it. Make sure I'm cutting off just what I want to cut off. Make sure we're in focus. And then hit my coolant back on. Start making my cut. All right, so after checking my setup sheet, it tells me that I need to flip it over. I'm going to set it in there. I'm going to 0 on the unmachined area. And this second operation is just going to remove the head. It's just going to do a facing operation to get it down to the machine surface. So this is not too critical on the measurement, but we need to be within ballpark here. And I don't really tell the students that. Tell them to measure it correctly on the little edge, and then we can run this facing operation. So we are now in the right vise on my machine. We could use parallels. We could go back in the Talon grip vise, but if we use those Talon grips now, they are going to do damage to our final surface. So I have, these are just regular steel soft vise. I've gone through and machined, so there are 2 different levels on them, so we can do this whole operation without actually having to use parallels. So we're going to take it, I'm going to put it on the upper area, and of course get it snug down, smack it in. Get it good and snug. And we need to do our work offset again. So we've changed, we always change between our operations. We're always going to go back and do our work offsets. So I'm going to plug in and pull out the sensor. All right, so we'll come over. This one we have to be a little more careful with because I do explain to the students the little ball needs to be on the flat edge there. So again, it takes a little bit of time, but we're not too worried about that. Phase 1, enter. All right, so then we'll come down. So I can check by going up or down, and as long as it doesn't move a ton, that means I should be on the thicker part of the ball. Come on over, 0 or out. Change G54. Check to make sure that the number actually changed. Then come back away from the block. Move to the front. Grab our Y. Write that into G54. Back away. Up a little. Over the center. Come on down. 0 out my Z. Measure right, and that number looks good. Everything changed there. Pull my sensor up off the metal, and then we're going to go back into our program. We need to pull up level 2. So names of stuff, that's again in the setup sheet. That's there for them to see. So at this time, I'm not going to add an inch to the common Z. I'm just going to hit the green go button and be ready to slow it down. There's my face mill. Come down, slow, slow. And as it starts moving, we'll take a look. It looks like it's going to basically take the hat off. We'll let her rip. So we are at 2,500 RPMs, 30 inch per minute. And this is a 2-inch 4-insert face mill. So there we go, we have our block there. We got the hat off. We are approximately the correct size now. All right, we are moving on to operation 3. So now we are going to create the thumb hole. We're going to do our chamfer on the back side. So because, especially with our chamfer, we know we need to be lined up really well, we need to remeasure our work offset. We can't use that rough estimate that we had from our unmachined side. So we're going to go back, pull up our sensor. Come on over by our block. It is the same front corner. I know I probably should use a different spot, but on the back jaw. But I do like it's not something that I'm going to have students change too much. And I want the repetition of them going through and seeing this over and over again. I really like the idea that they have to go through and change this and check this 5 times for this one operation. It really helps reinforce the steps involved. So again, we'll make sure we're down far enough. We're on the big part of the little ball. Needle starts moving. Move to thousandths. Get us so we're 0-0'd. Measure right. We notice it doesn't change a ton. That's good. Move back away. Again, even backing up, I want them at that 1x. I don't want it moving very fast when they're using the sensor when it's touching the metal. And from what I've watched, the kids are really, really careful with it. They have been. I'm not sure how my sensor, the tip is really close to being broken, but not yet. And that's, I mean, that's been over a year and a half, and quite a bit of use in here. So I've been really happy with that. I do have an extra one ready to go, but hopefully I don't need it, or at least not for a while. I do kind of try to hammer home the cost of stuff with this. I think that helps students kind of understand what's going on, and they also respect it a little bit more, and I think even appreciate the fact that they get to use some of this stuff. And again, we're very fortunate, being a small school, to have something like this in the shop here. All right, so we got my X, we got my Y, we got my Z. Get it out of the way because I like it being up before I do a tool change. We're gonna go back to program list, bounce down to level 3. Cycle start. So just like we did before, this is our first roughing cut of the thumb hole. And again, it's very easy to take it here. I can look and see I got 165 thousandths left before it thinks it's at 0. Looks about right. Coolant back on and let her go. Easy one done. Cycle start, since I got my optional stops on. The optional stops are, you know, it's a good thing also. The students get to see what each tool does, so they get to see how it's really stepped down from a roughing pass. And then after we go to the 1/4 inch tool, they can see how much smoother it is after an intermediate step, and then once we do our final pass with the 1/8 inch ball end, they can see how that really improves the finish each time. There's my little goof again. I don't think it really cuts anything. So there is our thumb hole all finished out. Last step, we gotta do some chamfering around there, knock that harsh edge off. All right, so there is the end of operation 3. So we have this almost done. All we got to do is drill the little holes for the vials themselves. All right, so we have our final product out of the machine. Engraving looks good. Finish looks good everywhere. Holes look good. We got a little bit of a chip in where it went through on there. So we simply got to get out. So I usually use this. I like this tool. I can go in and I can kind of get the back side. It's not the best, but it works fairly good to get that little bit of chip out of there. Now we're going to take our little vials. We should be able to push them in. Use a pencil to set them all the way in. There we go. Repeat it on the other one. I've found that my tolerances are tight enough that I don't actually need to glue them in or anything. They tend to just stay in there. Well, that's the level. 5 operations. All 6 sides have been machined. Students have been really happy with this. I've gotten a lot of students that are excited, or even we've run out of time here and there, and they're like, I need to come in and finish that. I want to get that done. So I like seeing that. Gives students good opportunity to get on the CNC machine, get a little excited about machining and manufacturing. I work closely with a local manufacturer who's always looking for people, so this sort of gets them the step into that place. We've gotten a few youth apprenticeships based on using of this stuff, so it's been really good. Levels seem to be good. Checked them every now and then against a machinist level. They look pretty good for their accuracy. Durability-wise, not 100% sure what's going to happen to the aluminum, but it sure does make for easy machining in this machine, or any other machine. A Tormach, something like that, is going to easily be able to cut through aluminum like this. If you guys like what you see, I will have some of the files available. I'll make sure I have the SolidWorks files. I'll get some G-code. I don't know, because the G-code is with my machine, it may not work. It's relatively a standard controller. And I'll have some of that stuff available. I'll have the setup sheets. I'll put those someplace. I'm not sure where the WTEA is going to have them, but I'll have those available if you'd like to see them. The vials, if you guys, I can try to find some links, at least links to what I used for those. Shouldn't be too difficult to find. Hopefully these stand up. I'm not 100% sure how the aluminum's going to stand up over time, but it's a nice little project. It's got our name on it, so it looks good. The kids kind of remind it, show other kids. It's been good. So thank you for joining me. Let me know if you guys got any questions. I'm more than happy to answer them about the project, about some of the tools we use, some of the other stuff. All right, thank you.